Okay, like I said in the last video, there's just one more thing I wanted to mention from section 4.3. At this point, any point on the unit circle, we should be able to find all 6 trig functions for. A lot of them you have memorized. If you don't, you should be able to calculate them relatively quickly. The problem is, when we're dealing with problems in the real world and just in the real xy plane, we're not necessarily on the unit circle. Most of the time we won't be. We'll just have random points somewhere on the plane. And what do? Well, suppose we have this point 512 right here. Well, if I want to say find the sine of the angle you get when a line segment goes from the origin through 512, well, draw that line segment. Then this is my theta that I care about. And what can I do? Well, clearly I can just draw a vertical line right here. I get a right triangle. Since this is a point 512, I know this side is 5, this side is 12, and I can use the Pythagorean theorem to get the third side really quickly. 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. That gives me 169 equals c squared, and then c is equal to 13, the square root of 169. So I can immediately get all 3 sides of the triangle. And then if I wanted to find sine, well, I can use my SOHCAHTOA that I know. Sine is opposite over hypotenuse. So even though I don't know what the angle is, I can just say sine of theta equals 12 over 13. And I'm done and good to go. We actually did this back at the beginning when we started our right triangle trigonometry. So that's pretty straightforward. But when we did these triangles before, we restricted ourselves to the first quadrant over here. What happens if I decide that I have the point negative 512? Well, now what do? Well, since all of this trigonometry is based off of triangles, just draw another triangle. Obviously, this side is still 5, this side is still 12, and the Pythagorean theorem will give me that this side is still 13. Now, if I wanted to find sine of, say, theta, where this is theta, well, it's opposite over hypotenuse again, just like this, which is 12 over 13. And I get the exact same value, which makes sense. It's the exact same triangle. But now, suppose I go back to this one, and I want to find cosine of theta. Well, again, cosine is SOHCAHTOA adjacent over hypotenuse, so it's 5 over 13. Over here, if I want to find cosine theta, I still get 5 over 13, but is that right? If we remember from our unit circle, I don't want to draw the unit circle on top of this because then it'll get really messy and hard to see. In terms of the unit circle, sine was our y value, cosine was our x value, which means in the unit circle, since sine is the y value, in the first quadrant and the second quadrant, sine was always positive because it's above the axis. And for these random triangles that I drew at these points, sine is always positive, so that makes sense. For cosine, cosine is the x value, and in the unit circle, in the first quadrant, cosine was positive. In the second quadrant, cosine was negative. Which means if some point on the unit circle, for the sake of argument, we'll say it's right here, if some point on the unit circle here has a negative cosine, then it doesn't make sense for the cosine of this point in the same quadrant to be positive. It should be negative 2. So we'll just say it's negative 5 over 13. And essentially, as long as you understand the unit circle and you understand what quadrant your point is in and the value of on the unit circle of the given trig function and whether it's positive or negative, that applies to any point in any angle in the quadrant you're talking about. What I mean is, let's see. Suppose we draw our real plane right here, and we have the point negative 5, negative 6, negative 8. Well, there's that. I want to find the trig functions associated with the angle going through there. So I do the same thing as before. I draw a line to the origin. Then here's my theta. There's my reference angle. I then draw a triangle. If that's -6, -8, that means x is -6, y is -8. And one way to keep these things straight in your head, the sides of a triangle obviously can't be negative in the real world. But for the purposes of this, if you want to help yourself keep the sign straight, write those sides as negative because they're negative. And then that will just tell you whether your sine or cosine should be positive or negative. The hypotenuse here, -6 squared is 36, -8 squared is 64. That equals c squared. 36 and 64 is 100. So c has to be 10. And this side is 10. Now find your trig functions. Well, sine of theta is equal to opposite. Again, it's 8, but since it's going down, just call it -8. So it's -8 over 10, which is -4/5. It's below the axis. Sine should be negative when it's below the axis because it's the y value. So that's logical. Cosine of theta equals adjacent -6 over 10, which is -3/5. Again, cosine is the x value. That point is to the left of the origin. It should be negative. Tan theta is opposite over adjacent, which is -8 over -6. All of you remember two negatives cancel, and this reduces to positive 4 over 3. And we remember from our unit circle, tangent is positive in the first and the third quadrants. So it all kind of works out nicely. Essentially what this means is, we can take our ideas about the unit circle if you fully understand it, and you can apply it to any point in the plane anywhere, and given any point, say we have this point right here. As long as you plot that point in the plane, and then draw a line segment from the origin to that point, you can immediately get a right triangle. You can find the lengths of these two sides, because you know what the point is. That gives you the hypotenuse, and then you can find your trig functions, figuring out what quadrant you're in and whether that trig function should be positive or negative. Make sure you understand this, because if you grasp this and can do this, just randomly plot points in the plane and find trig functions associated with them, if you can do that, then a large portion of what we do in this class throughout the rest of the semester will be almost trivial to you, because it's all based off of that idea right there.